Hello, my name is Jonathan Bogner. I'm a systems engineer, net dev engineer here at Lumina Networks. And today I would like to have a discussion with you about an opportunity that we had recently to participate in an interoperability event. I've spent the last couple of decades of my life working with both for and with the service provider community to work towards network automation, work towards interoperability and understanding how to scale networking, how to scale the OSS, BSS systems that support that networking. And as part of that here at Lumina, we recently had this opportunity to participate in the EANTC, the European Advanced Networking Test Center event, where to my surprise, I was able to see and work with a number of vendors, common vendors that we see in the networking space in service providers, and actually experience a new feeling of excitement as we're moving towards this new world of interoperability and service providers actually getting some of their wishes and demands and just general needs met by this ability of software-driven networks and the ability to automate those networks and do closed-loop functions and have multi-domain and multi-vendor interoperability actually be a reality. Lumina has spent years working in the open source space with the Open Daylight Controller and additional modules and applications that we've built surrounding that. We're going to talk about a few of those today that we actually leveraged as part of the Interop event and proving that interoperability, when achieved by the vendors, actually creates an open and successful network deployment and network automation solutions. So let's get started with talking about a couple of these solutions that we deployed. One of the key solutions that we deployed was the Lumina Network Resource Manager, the Path Computation Engine. In this particular test case, the NRM, the Lumina NRM solution actually operated as the network path computation engine for a multi-vendor network. In this case, you can kind of see the solution here where we're peered into network node 1 and 2 here, with 3 and 4 being next hop routers. And the ability to essentially through straight up BGP LS connectivity, so the controller, the Lumina controller, participates in the forwarding plane as a BGP participant, and therefore receives link state updates. So we discover topology. And on top of that, then we apply computation with intent. In this case, it was a cost-based intent that was used. And the controller has a UI that allows you to kind of visualize the topology and see the paths end to end, as well as monitor and watch those paths as things are changing in the network. So link updates from BGP indicate changes. And so a path was provisioned, and you kind of see that path 1 going this way. So it went through 1, 3, and 2 to get to the end state. So a path was provisioned and LSP was provisioned through the PCEP protocol. So again, an open standards-based protocol with 2 different vendors. So network node 1 is, it was Juniper, and network node 2 was Huawei, I believe, or vice versa. Doesn't matter though, it's a multi-vendor deployment. So you get this ability to see a path being generated, and then they verify that traffic was flowing, and then a change was made to the link cost here on 3 to 2 or 1 to 3, one of the link, or 3 to 2. So the link cost was changed, and automatically the path was rerouted by the controller. So the controller got a link state update that the cost of the link had changed, which affected the intent of the path. and the path was then optimized and rerouted. And within almost instantaneously, as we see those changes happening, then the path was rerouted to follow and adhere to the intent of the path. So that ability to happen, and then there was a disconnect process that was gone through as well to ensure that the paths could be taken back down. So failover and other use cases can be tested. We've done a number of tests with customers. We have this solution running in actual customer accounts in production today. So you have this ability to use a centralized control plane with path computation. So cool interop. It was fun to experience and interact with the vendors and see that, oh, in certain cases, if protocols weren't lining up, then it was, the interop event was, it was fun to work with the different carrier customers or the vendors to achieve those goals. So fun exercise. We'll talk about this multi-domain, multi-vendor controller. This was one of the most comprehensive tests and the most vendors involved in a test case. In this case, each of these routers in this solution are a different vendor. So we had Metaswitch, Nokia, Juniper participating in this, as well as Huawei, I believe, on the vendor side router. At the domain orchestrator level, Cisco performed this role and was transmitting down to the various controllers. And I believe Cisco was the controller in domain 1. The Lumina controller was in domain 2. And in this case, we actually deployed what we call our LEAP solution. It's the Lumina Extension and Adaptation Platform to actually solve this problem. So we were able to dynamically deploy a service YANG so that the orchestrator could send a simplified service request with only the service parameters that were necessary, as opposed to a full configuration. They didn't have to know anything about these devices under the hood. And the LEAP engine then was able to deploy a RESTconf API automatically based on a YANG definition to the northbound. And then with a workflow engine, Camunda under the hood, we're able to then do the processing and break down that inbound service intent and deploy the various configurations. We also have a solution here for model-to-model translation called Lumina Service Mapper. That gets utilized by the workflow engine to translate each of the vendor-specific netconf protocols and payloads on the southbound side of things. So that all happens kind of coordinated inside of the LEAP infrastructure here. So in a sense, you're getting this ability for the orchestration, whatever that northbound ordering / portal is, to send a service request to the controllers, and the controller will then handle translations and understanding of how to do the configurations on the individual devices that are responding, that need to be configured for that service. And the really exciting thing about this is we managed to do this all in just a few days. So all of the vendors participating and adapting and working together to come to a common definition of what these interfaces would look like, and getting those built, designed, and deployed, and the workflows to happen. To have that happen in just a few days is really exciting, because it really supports this concept of open standards, open networking, and open protocols, and what comes with that. So this netconf protocol on the southbound makes things easy for the controllers to understand what the capabilities of the devices are. It's all automatic through the protocol, and then the controller can then handle the translations and functions associated with that. So very exciting, and it was really exciting to have the orchestration send a request, and within a few seconds have the entire path up and running and verified and pushing traffic through the network, and then tearing it back down in a similar fashion. So these concepts start to come together. So very exciting, fun to see that the vendors are starting to understand this need for interop, and that the service providers are driving towards the requirements that vendors must comply with open standards and protocols. And that's where, again, the open source community that we participate in, or the number of open source communities that we participate in, are driving towards these standards as well, providing easier integration and easier access for service providers to start this journey sooner rather than later. So very exciting stuff. This was an EVPN service creation where instead of having an orchestrator make the call, we actually used a simple Postman REST API call to trigger the workflow and controllers. This is a subset of the previous multi-domain, multi-vendor with the orchestrator. This was just a subset test of that to ensure that we get, we use this as the stepping stone to get to the more comprehensive multi-domain. So similar concepts here. This is still using that same service yang coming northbound, passing a request to the controller with the workflow engine, then translating and handling the translation southbound. So Juniper, Nokia configuration in this particular test case, and ensuring that traffic was flowing and passing. But again, this concept of the model-to-model translations being leveraged inside the controller, which insulates that northbound, is critical to a service provider's success in network automation. So exciting, fun stuff. As we proceed down the stack, then this was just the simple netconf use case. So again, this is this is again a subset test, but this allowed us to test with multiple vendors that weren't necessarily participating in the larger service solutions. So we had some meta switch and dealt with some interesting yang issues that we ran into with getting that mounted onto the controller, but we were able to successfully work with the vendor and actually achieve mount and netconf protocol connection and understand the discovery of those devices. So again, what I want to take away from this is that the vendors are working now to achieve interoperability via standards that the communities and service providers are driving. And it's really exciting to see this starting to come together and starting to actually take off in the networking space that has commonly been so proprietary, and each vendor implementing their own protocols and their own capabilities with minimal interop requirements and tending to try and achieve, we'll call it vendor lock by having advanced capabilities. Again, there's nothing, it's not to say that proprietary is bad, it's just not interoperable. And that's where leveraging the communities to achieve interoperability and ensure that the protocols and standards support all of those capabilities that have been commonly proprietary is a win-win for everyone. And it's a win for the vendors, it's a win for the service providers, it's a win for the software solution sides of things, the open source communities. So very excited that we got to participate in this, and we'd like to thank EANTC for their support and their help during this process. And the vendors that we worked with, the technical folks on the ground were fantastic. So very excited to see this happening and look forward to future opportunities to work with you and the vendors and the communities to achieve full closed loop network automation in the future is the goal. And we'd like to see you doing that in your labs and in your production systems today, as we are with our customers today. So have a great day. Look forward to hearing from you.